Alright, so hi guys. I do apologize for the lack of uploads. I've been busy. In this video, what I want to look at is I want to look at a problem from Calculus 2, and we want to evaluate this indefinite integral using trigonometric integration. So here, one of the formulas that we are given, and I'm going to try my best to type this really quick or write this down really quick. Give me 1 second. Okay, guys. So I do apologize for the wait. I had to type down these formulas here. So this formula up here, this one is for when the power of cosine is odd, and this one, well, let me do this color here. This one is for when the power of sine is odd. Of sine is odd. Okay, so here, as you can see, they are both odd. So I believe either one of these works, as long as we, or actually, no, yeah, either one of them works. So they're both odd. So I believe if that's true, then you can definitely do either or. I don't think it would matter if you did one or the other, as long as you do one of them. So here, I'm going to go ahead and use this rule here. So let me use the first one, the sine to the m of x. So here, the way that I did it is, number one, I went ahead and split cosine cubed. So as cosine squared x times cosine x. So basically, we are going to go ahead and say the following. So this ended up being, so when I say the integral of cosine cubed x sine x dx, this actually ended up being the following. It's going to be the integral of cosine squared x times cosine x, so that's this part, and then times sine of x dx. Okay, and then what I did, so if I go ahead and rewrite it here, I have cosine squared x times cosine x, and there's a reason why I'm rewriting it. And so here, we go ahead and say, now that number 2, we want to use the Pythagorean identity. Okay, so the Pythagorean identity for the for cosine squared x. So as y'all know, the Pythagorean identity, sine squared x plus cosine squared x equals 1. So this is the Pythagorean identity. And if you solve for cosine, you're gonna get that cosine squared x equals 1 minus sine squared x. So we're gonna use this, we're gonna use it for this part. So again, that's what's gonna go there. And so, and these two are the same thing, by the way, but again, I'm gonna rewrite it so that cosine squared x is in terms of 1 minus sine. So here we're going to have the integral of 1 minus sine squared x. And then, so that's what this part is. And then we're going to have times sine x. And actually, let's do it times, hold on, guys, times sine x times cosine x dx. So now what we can do is use substitution. So that's number 3, okay? So now we can use substitution, and you have to be really good at recognizing, at detecting a use substitution here. And sorry for my handwriting, my pen is kind of acting up. So here, clearly, if I do let u equal sine x, then my du will be cosine x dx. So basically, if I let this be u, then this part will be my du. So again, if this basically ends up being 1 minus, and I can let sine squared x be sine of x squared. So that's what I'm going to put in for this part here. So I'm going to say 1 minus sine x squared, and then I'm going to say, and actually let me just color code here, sine x squared, and then times sine x, and then times my cosine x dx. So again, I'm just going to state u and du. So u is sine x, and du is cosine x dx. So if we substitute, we're going to have the following. The integral of 1 minus u squared, and this is all multiplied by sine x cosine x dx, times u, it's going to be times u, and then du. So again, this part ends up being a du, and so then we have the following. The integral of u times 1 minus u squared du. And if we integrate by using power rule, so let's go ahead and the next step here, so number 4, is to distribute and integrate by power rule. Okay, so we're going to distribute here. We're going to have the integral of u minus u cubed. And again, I'm going to do it like this, u cubed. And so now we're going to use the power rule. So the power rule, if I have u, the integral of u to some power n, then this is going to be, and it's du, then this is going to be equal to u to the n plus 1 to the n plus 1 over n plus 1. Okay, guys? And so using this rule, we have u, so it's going to be u to the 2 over 2, because 1 plus 1 over 1 plus 1, and then minus u, and actually let me do it this way, and then u to the 4th, so it's going to be to the 4th over 4. And now the last part will be to substitute u back in. So, and it's plus the constant of integration c. So substitute u back in. So basically, this stuff here. So u was sine x. So we're going to have to say it's going to be sine squared x over 2 minus sine to the fourth x over 4 plus c. And again, u was sine x, and we just substituted it over here. So so therefore my integral of cosine cubed x sine x dx, thus integral of cosine cubed x sine x dx equals sine squared x over 2 minus sine to the fourth x over 4 plus my constant of integration c. And that, guys, is my final answer for this problem. So that is going to be it for this video. If anybody has any questions, please let me know. I do hope this helps, and if I did go too fast, I do apologize. I do have a tutoring session in like 15 minutes, so but again, you can rewatch the video. The idea is you have to be really good at u substitution, and you have to know your formulas for when the powers of sine and cosine are odd or even, so on and so forth. So that is going to be it for this video, guys. And with that being said, thank you so much for watching. And also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.